Alright, y'all, we're going to talk about the law of sines today. You know a little bit about this, but we're going to talk about it in more detail. So please make sure you have a calculator and that its mode is in degrees. Okay, so as a review, law of sines, it looks like a proportion made of two ratios. We've got some side over the sine of an angle across from it equal to another side over the sine of the angle across from it. And we're only going to choose two of these. But I also want to emphasize that you could see this version. I'm pretty sure that's probably how you were taught in geometry, is sine of the angle over the side across from it. But it really doesn't matter which one goes on top with the proportion, as long as they match up angles over sides all the way through, or sides over angles all the way through. I usually set it up so that the variable, whatever I'm solving for, is on top. That just saves a step when you're throwing it in your calculator, but really it won't matter. So here's how we know whether we're able to use the law of sines. First thing you're going to do is find your variable, or whatever you're trying to solve for, and you're going to connect it to the thing across from it, whether that's an angle or a side. So we've got a side, we're going to the angle across, and then you look at the other information you're given in a picture. If you can create another pair of one angle and the side across from it, then you're using the law of sines to solve for it. So in this case, we do have that situation, and we're going to set it up. So it'll look like x on top over sine of the angle. You're always going to put the sine with the angle. It doesn't necessarily have to be on the bottom. Okay, but because I put sides on top, we'll have to write the second part, 18 over sine of 110. And here's why I like to put x on top. There's exactly one step to solve for this. You multiply by the sine of 40. You don't have to cross multiply. Okay, so then in your calculator, we're just taking 18 sine 40, and then you'll have to either close this parenthesis or just hit enter before dividing by that next part, sine of 110. So this is about 12.3, and because it's a side length, I'm just going to put units on since 18 wasn't labeled. Same thing's happening on the next one. We're going to start finding the variable and connecting it to the thing across from it, and we're looking for another pair. In this picture, 5 and 50 are not across from each other, okay, but we can't say it's not law of sines until we're sure that everything's in the picture that is able to be found. Okay, so looking here, we can't determine this third side because we only have the one side given to us, but we can determine this third angle because we know that in any triangle, not just a right triangle, the three angles have to add up to 180. So this has to be 60 degrees for those to add to 180. Now we have that pair making it law of sines. So x over sine with the angle 70, and then 5 over sine of 60. Okay, so a lot of this is just going to be done in your calculator after you write that down for me. So that multiplies over 5 sine 70. Again, hit enter, and then divide by your sine 60. Okay, if your numbers ever look unreasonable, that's when you can go back and check, did I hit enter, did I close the parenthesis, one or the other to make it work out for us. This is about 5.4, and how we know it's reasonable is by looking at our picture. Recall from geometry, the biggest side has to be across from the biggest angle, and the smallest side has to be across from the smallest angle. Okay, so our biggest angle was 70, it has to be the biggest side, that is our biggest number. Same thing over here, our biggest angle was 110, and 18 was larger than that number we solved for. The next couple examples you'll notice are variables on the inside. Same process, we're going to match our variable up with the thing across from it and try to find another pair. In this case, we've got our 20 and our 70 set up. Okay, but because A is an angle, remember angle has to go with sine. So this will be sine of A over regular 17 equals the sine of the other angle, 70, over 20. And because of this sine attached to the A, there's just one extra step for us. Okay, first thing is the same. We're going to multiply by our denominator over. Okay, and I like to put it in the front because it makes things easier to type in. So 17 sine 70, hit enter, always before dividing. You'll notice this is a really ugly number, but it should make sense to you because this is actually saying the sine of A is about that value. And remember, sine for right triangles is opposite over hypotenuse, but in general, when we think about the graph of sine, the biggest number possible for the ratio is 1, and the smallest possible is -1. So this should always be a decimal. Okay. When we want to think about A, though, we have to realize that this is an angle, which means we have to use the inverse in our last step. Okay, so we're doing the inverse sine of that answer that we just got, and then 53 is our angle in degrees. And again, you can check your picture to make sure it makes sense. So this, if it were 53, is across from the smaller side, makes sense for us. Alright, what I want you to do is pause the video and try that next example for me, please. You should have had it set up sine of B over 10 equals sine of 85 over 22. If you had these flipped around, as long as you had them flipped around on both sides, that works too, just with cross multiply. But then we got sine B is about 0.4528. Again, decimals are good news. We're doing the inverse sine of that to get our angle of about 26.9 degrees. Okay, and if you check that, we expected to have a smaller angle than 85 since 10 was smaller than our 22. It all works out. Okay, but here's what's new. When you were taught about law of sines the first time around, you probably weren't taught about this is actually an ambiguous case where our calculator gives you one answer, but there actually may be a second answer. Okay? And that comes directly from our idea of the inverses that we learned in 5.2. Remember, those inverses are restricted so that they are functions, meaning our calculator can only give us one answer even though there are multiple answers that may work. Okay, but we also have to think about, we don't want infinite answers anyway because we're restricted by this is a triangle, and the only angles possible in a triangle are from 0 to 180 degrees. So what we're going to do is find, first of all, our angle B, and then we'll talk about that second potential solution. Okay, so same process as before, sine of B over 62, and then sine of 58 over 54. We'll just throw that in the calculator. 62 sine 58, enter before dividing. That's our ugly decimal. I'm going to write it down, and I'm going to ask that you write it down as well for this one because we want to talk about why this is special. So sine of B is about 0.9737, and then take the inverse of that. We get about 76.8 degrees. Okay, but we're also asked to find the supplement of that angle. Okay, and remember, supplement is just the angle that makes that add to 180 degrees. So if we take 180 minus that number, we get our second option of 103.2 degrees. Okay, so what I want to do is first talk about why this is even a possibility, and then we'll talk about if it actually works in our situation. So if you remember from the early part of Chapter 4, when we were talking about angles and supplements, we did so on the unit circle. So I wanted this number so we could kind of get a visual. 76.8 degrees on the unit circle is right about here. And we're saying the y value of that is about 0.97. Okay? And then 103.2, here's 90, would be here with the same y value. Okay, just by symmetry, thinking on our unit circle here. And these are the same sine values because if we draw in our angles here, they're the same reference angle. Both of them are going up, so they both have positive sine values. Okay? When we deal with the law of sines, we want to find the supplement because 103.2 degrees is a possibility for a triangle if you're dealing with an obtuse triangle. So what we do have to check for is, does it work with our specific numbers? Because obtuse triangles can exist, but we want to make sure they coincide with the numbers well that we already have. So how you'll check this is first find the supplement, and then two, what I want you to do is just have a visual for the second part. So this is 54, this is 62, this is 58. That's all of the things we are given. What we want to do is, if I put 103.2 in here, is ask ourselves, would it work? So two things you check. Would it work with the numbers across from them? So 58 is across from 54, 103.2 across from 62. That checks out because big side goes with big angle, small side with small angle. The next thing you want to check out is, if you put those angles together, does it go over 180? Because the only way you can have three angles in a triangle is if two of them are less than 180 together. Okay, if we go over 180 here, there's nothing left over for that missing angle. Okay, in this case, they are less than 180 when you add them together. So this actually works out. There are two angles here. Okay. Last thing I want to point out here is just one more thing with this idea. We're saying that the sine of 76.8 degrees is the same as the sine of 103.2 degrees. I hope that's familiar to you, because we're saying that the sine of one angle is the same as sine as this came from 180 minus the angle is the same as the supplement. This is literally our supplement theorem, and that was our visual for it from chapter 4. Okay, so we're going to go back to those two problems that we looked at first with solving for angles and just check if there was another angle that we missed. Okay, so here's how it works. You have your first angle already. That was done earlier. What you're going to do is find the supplement, okay, just 180 minus that number, and then you're going to write it down, 153.1. Okay, but you're going to just check it visually by putting it here, 153.1 degrees, and see if it works. Okay, if you look here, it says our biggest angle is across from the 10. It doesn't work. That's not, if this is the bigger side, then maybe, but this is the smaller side, it doesn't check out. Another thing you can look for again is adding those up. These together go over 180 degrees. It doesn't check. Okay, doing the same thing here. If we take 180 minus 53, we've got 137 degrees, 127 degrees. And with that, we're going to do the same thing. We're going to put it in our picture for the missing A, and we're going to see if it matches up. This is the bigger angle, but it's not across from the bigger side. It does not check. Okay, if you think about it this way, 127 plus 70 goes over 180. It does not work. You can use either of those things to check, but you should be able to figure out whether that second angle is a possibility or not for either of them. So we're going to just practice that on the next one. So we're going to decide, based on this information, would solving for the angle produce one answer exactly, two answers, or actually there is a possibility of none. So let's check it out. We're given three pieces here, so I want you to draw a triangle and put those three pieces on the picture. So we're given an angle, 35 degrees, and we just have to make sure that since this was F and this is F, that 50 feet goes across from it. And then your 90 foot can go wherever else on your picture. Okay, so the thing we're going to solve for is always across from that third measurement, and we're going to set it up. Since it's an angle, I'll put sine of x on top over 90, and equal to sine 35 over 50. just in your calculator, we're going to do all the work for this one. So 90 gets multiplied over sine 35, enter, divided by 50. Okay, this is 1.0324. I hope you recognize that that is a problem already. But if you do your inverse sine and type that in, it will give you an error. That's because our sine of x was greater than 1. So this is not a triangle that exists. So this is a situation that would have no possibilities. We're going to do the same thing on this next one. Just drawing out a picture, 53 degrees here. Y goes across from it, so that's 19 yards. And then second side gets to be 7. X goes across from that, and we set it up similarly to the last one. Sine of x over 7 equals sine of 53 over 19. And we're just solving the same way. Multiplying that 7 over. So 7 sine 53, enter, divided by 19. That looks better. That's a ratio that's actually possible. Inverse sine of that decimal is about 17.1 degrees. Okay, from there, we're going to find the supplement of that. And the supplement of that comes from literally just 180 minus the number. And we've got about 162.9. And we want to just check that with the original. So I'm going to put it in this place here, 162.9, and just check her out. Okay, so here those go over 180. That is not a possibility. So this is just one triangle for this one. Okay, with that, what I want you to do is pause the video and try number 10 and number 11. And see if you can decide no triangle, one triangle, or two triangles based on that same process. Alright, number 10 had two triangles because when you found the supplement, 118.6 was the bigger angle across from the bigger side, so that didn't cause problems. Or 118.6 added with the original angle was less than 180, it worked out. On this one, number 11, that sine ratio was greater than 1 again, so we have no triangles that are possible with those values. Okay, so now that we know an idea of what is possible and not possible, we're going to go ahead and solve two problems all the way. And when I say solve all the way, I mean they'll give us some parts of the triangle, and our job is to find the rest. So we're going to draw this picture just a little bit bigger than the last ones, because we're going to fill in all the parts. So this is 60 degrees here. Across from it is 47 feet, and then our next side is 51 feet. And we're always going to start with across from it. This process matches exactly what we were just doing. So sine of x over 51 equals sine of 60 over 47. And we're putting that into our calculator. 51 sine 60. Enter, divided by 47, and we're taking the inverse sine of that. Our number is going to be possible here. So this is about 70 degrees. Okay, we'll go ahead and put it inside our picture for this one. Then we're going to solve for the second possibility. Remember, that's just found by the supplement of this thing. So the supplement of 70 is 110. I'm putting approximately because we rounded on that one. And we're going to check it with our original. So if I think about 110 degrees with 60 degrees, that makes 170. A second triangle is possible. And for these ones, I want you to actually draw the second triangle. And you can draw it the same way every time, even though this is definitely not how it would look. Okay, so we've got 60 degrees here, 47 feet, 51 feet, and we're putting our second option in there, the 110. Once you have that, we're going to find the third angle because that's the easiest thing to work with next. Okay, this is just by knowing the three angles in a triangle add up to 180. So you'll take 60 plus 70 and then subtract that from 180. So this is 50 degrees. Again, I'm putting about because that 70 was approximate. Same thing over here, 60 plus 110, subtract that from 180, and you've got approximately 10 degrees. So now the only thing left on this triangle is the missing side, so I'm going to pick a different variable than x and set that up. So we're going to use law of sines again for solving for this side. We're just going to use it with the sides on top. So y over the sine of 50, and we're going to set that equal to one of the other pairs in the picture. I like to use the pair they started with because that's going to work for both triangle problems for both different y values. Okay, so here I would use 47 over that sine of 60. And then, throwing it in my calculator, it's just 47 times that sine 50, enter, divided by the sine 60. We've got about 41.6, and it's talking about feet. And we're always going to check our numbers that they all make sense for the problem. Smallest side should be across from the smallest angle, largest side across from the largest angle, and then middle guys go together. Now we're going to do the same thing over here with our y again. And this process is going to look the same. The only thing that's going to change, in fact, is this number right here will be our 10 instead. Okay, so y over sine 10. We're using the same pair, the 47 over sine 60. So then typing that one in, we're going to have 47 sine 10, enter, divided by sine 60. So that one's about 9.4, which is quite a bit of a difference from the last one, but it just has to match the individual triangles. So if you look at this, 10 degrees was way smaller than the others, so it makes sense that our number 9.4 is smaller than our other sides. It matches up. Okay. On this next one, we've got the angle V being 90 degrees. And even though that's a right angle, I'm going to do this with law of sines just in case you were to miss that. So this is 90 degrees, and then 70 across from it, and then 56 somewhere else. Setting it up the same way. Pause the video for me and solve for x and check the supplement. Okay, in this case, when you did your sine x over 56 equal to your sine 90 over 70, okay, you should have gotten 53.1 degrees. And what I want to pause to talk about real quick is why this works for law of sines just like it does for a right triangle SOHCAHTOA. So I'm going to draw this as actually a 90-degree angle, solving for x. This was 56, this was 70. On a right triangle, this would be the opposite and the hypotenuse, which means sine. And then sine of my angle x is equal to 56 over 70, and I would just use the inverse on that. Well, sine of 90 degrees is actually 1. If you don't believe me, you can type it in. Or remember, sine of 90 degrees, y value is 1. And then if you multiply that 56 over, it says the same thing, sine of x equals 56 over 70. Okay, so even if you didn't recognize it as a right triangle, this one will work with law of sines. Alright, then hopefully you found your supplement. And the supplement of 53.1, we're just taking 180 minus that, and checking it with the original. So 126.9. If you check that with your original triangle, 126.9 plus 90 goes over 180. So that one does not check. So in this case, you only have the one triangle to solve for. So you've only got this angle and that side left over. I'm going to have you pause the video once more to finish that one up for me. Remember this, you're just subtracting to find every time. Okay, so 90 plus 53.1, take 180 minus that, and you get 36.9 degrees, approximately, because that was. And we're using that number to solve for y. So y over sine 36.9 equals 70 over sine 90. Again, sine 90 is just 1. Okay, so you just multiply that over, and you get about 42.0. We're going to put it on our triangle with a label. Checking out all of our numbers, small angle with small side, big angle with big side, it works out. Last thing that's new is dealing with the area of a triangle. We know area of a triangle as 1/2 base times height, but in order for this to work, you have to know the height of the triangle, which means the altitude, shortest distance from a vertex to the opposite side. That was the wrong drawing here, this way for that one. If we wanted to draw this one, it'd go down this way. Okay, but that is not easily found. There's a formula, and I want to show it to you, and then I'll show you how it works. This is for triangles that are not right, but have a special case of side angle side, where we know one side, the angle in between, and the other side around it. So for this, our area formula is 1/2 AB sine of C. I'm going to illustrate this with a really obtuse triangle. Okay, so suppose I have this angle, theta, and suppose the two sides I have around it were this side of the triangle and this length here. Okay, so that's my side angle side situation. But for the old school formula, I need 1/2 base times height. I have the base, but I don't have this height. So I'm going to let this height be h, and because this is a right triangle here, I can use SOHCAHTOA. This is the opposite side from that angle. This is the hypotenuse from that angle. So then I could say that sine theta is h over a, and if I wanted to solve for h, because that's what's in my formula, I would just multiply that over. So I just found out h is a sine theta, subbing that into my formula. 1/2 times base times the height is this part, is equivalent to this right here. They just put it in alphabetical order. Okay, so AB sine C every single time. Let's go to work on this one. We'll take 1/2 times the A value, one length, 11, B value, the other length, 11, and then sine of the angle, 99. And you just throw that whole thing in your calculator. And this is about, oh, I missed a 1 on there. It's like it seemed too small. This is about 59.8. And then it's centimeters squared since it's area. Okay, formula again, 1/2 AB sine C. Make sure you have this written down. Pause the video and take care of number 15 for me. The only thing you have to really check for is that the angle you have is between the two sides you have, and that's set up for us. So the rest is just making sure you throw it in your calculator correctly, and that's about 12.0 kilometers squared. Alright, last problem. It's not necessarily new in terms of things you've done before, but it is new in terms of this is a two-part problem, and I can see that because there are two different triangles here making up a larger triangle, and we only have a few pieces on this picture. So it says, suppose you're wanting to find the height of the White House using trigonometry and a clinometer app. This is just to measure angles. Okay, but you can't find your distance to the building because the hedges in front of the White House are blocking your path. Okay, so you can't actually measure this distance all the way to your White House because there are these little hedges in the way causing you problems. Okay, instead you measure the angle of elevation from the ground at two places 10 feet apart. So here are your two places 2 feet apart, and it's measuring the angle to the top of the White House from the ground both times. Okay, so that's the information we know. And in fact, that's enough information to solve this problem. Okay, so let's figure out how. We're trying to find the height of the White House. Okay, and again, we can't just use regular SOHCAHTOA because we didn't know this distance, those hedges were in the way. So instead, we got to be creative on how we're supposed to solve this thing. So we can't use the right triangles because we don't know this horizontal distance and we weren't given the diagonal distance. So instead, we have to focus on the non-right triangle. Okay, because that's actually the triangle we know most about. Okay, so the non-right triangle here is this one, and we have two pieces of information on it, and only one on this right triangle, only one on the big right triangle. Okay, so this is our focus. We've got the most information there. So with that, what we want to do is see if this other angle helps us solve for anything else on this obtuse triangle. So hopefully you recognize that these two angles form a linear pair, making a line. Okay, and if they make a line, they add up to 180. 180 minus 35 is 145 degrees. And if you know two angles, you can solve for the third. Okay, so taking 145 plus 32.5, I'll just show you so I'm not just saying it. 145 plus 32.5, every single time we've been doing that, and taking 180 minus that value to get the third angle. So this is 2.5 degrees. And the reason that's helpful is because now I can solve this triangle for either this missing side or this missing side. And that's super significant because the whole reason we couldn't use the right triangle is because we didn't know one of the other sides of the picture. We can use this obtuse triangle to find one of those. And it doesn't matter which one you go find. I usually like to use the outside one just because the inside of my picture is usually messier. Okay, so I'm going to put a different variable here. I'm leaving X for that. And I'm going to set this up. So there's a pair and there's a pair for law of sines. So y over sine of 145 is equal to 10 over the sine of 2.5. And we can throw that in our calculator. So 10 sine 145, enter, divided by sine 2.5. And that's 131.5. Now I'm only writing this, but we're going to actually use the whole number from our calculator when we go solve this. Okay, so in my work here, as I set this up, I'm going to use this 131.5, but when I put it in my calculator, I'll use the whole decimal. Okay, so now, here's the visual of what we have. Sometimes this gets messy, so if it helps you to draw out your triangle that you're working with, so this was the 145, this was the 2.5, this was our 10, and we just found this part. Now we're focusing on the big triangle. Okay, so the second piece of this is, here's what we're solving for. I know way in the corner is 32.5 degrees, and now I just found this number to be 131.5. Here's where SOHCAHTOA comes into play. This is opposite, this is hypotenuse. I can say that sine of 32.5 equals x over that 131.5, which means I'm supposed to multiply those in my calculator. I already have this number in my calculator, so I just have to take it times the sine of 32.5. And that gives me about 70.7. So the White House is about 70.7 feet. And these double step problems are the toughest that you're going to see this chapter. We will practice more of these.